A meteor is a space rock that enters Earth's atmosphere. As a space rock falls towards Earth, the resistance of the air on the rock makes it extremely hot. What we see is a shooting star. That bright streak is not actually the rock, but rather the glowing hot air as the hot rock zips through the atmosphere. When Earth encounters many meteoroids at once, we call it a meteor shower. Why would Earth encounter many meteoroids at once? Well, comets like Earth and the other planets also orbit the Sun. As a comet gets closer to the Sun, some of its icy surface boils off, releasing lots of particles of dust and rock. This comet debris gets strewn out along the comet's path, especially in the inner solar system where we live, as the Sun's heat boils off more and more ice and debris. Then several times each year, as Earth makes its journey around the Sun, its orbit crosses the orbit of a comet, which means Earth smacks into a bunch of comet debris. If any of those small particles actually make it through Earth's atmosphere, we call it a meteorite. These are a few examples that have been found on Earth. They can range from tiny, almost microscopic, to boulder size. Most meteoroids, though, burn up in Earth's atmosphere, and very few of them actually make it to Earth's surface. This is the Moon, which shows a lot of impact craters. These are formed when a meteorite actually hits the surface. Usually the meteorites or the meteoroids are going very, very fast, and so it creates a really big impact. Because the Moon has no atmosphere, we can see impact craters from millions and billions of years ago. This is the largest crater on the Moon. It's called the Aitken Basin, and it's at the South Pole. This crater is in South Africa. It's the largest known impact crater on Earth, almost 200 miles across. At over 2 billion years old, it is also one of the oldest. Because of erosion over this long time period, the crater is a bit difficult to see. Near Flagstaff, Arizona lies Meteor Crater, which is also called Barringer Crater in honor of geologist Daniel Barringer. The crater is 3,900 feet wide and 560 feet deep. The meteorite impacted about 50,000 years ago during the Pleistocene epoch, and at that time it was grassland and wood and was inhabited by mammoths and giant sloths. It hit with a speed of around 30,000 miles per hour. About half of the meteorite had been vaporized before it even impacted. These are the materials that we're going to use to do our impact crater demonstration: sand and powder detergent. These are metal filing pieces, these little metal pieces. And then we're going to use some different types of projectiles. We've got marbles, we've got rocks, and metal ball bearings. And this is a UV light to help us pick up some of the impact that maybe we can't see with just a camera. So I'm going to start out by creating layers. Just like our Earth, just like the Moon, there's going to be different layers of soil. So we have our sand, then on top of that, in one part we're going to put some of the dry detergent, and then over top of everything we're going to put the metal. Now you could do this at home by using materials you have in your kitchen. You could use flour, cornmeal, you could use cinnamon, or anything that's going to make a contrast, so that when you do the impact demonstration, you're going to actually see how the object hitting the surface actually affects the layers of the Earth. So I'm going to start with the marbles and the metal ball bearings. I'm dropping them from a height of about 2 feet. So what do you think is going to happen? Which is going to make the biggest impact? So we have the largest marble, and we have the small marble, and then that's the larger metal ball bearing, and then the small one is coming next. So how did the layers, how did they spread out from the impact zone? How are the rocks different? How is the impact different? Or do you think they're as heavy as the other pieces? And how does the weight affect the impact? And then we're just going to take a quick look with the UV light. It'll kind of help you see the highlighted impact zones and what kind of impact the different projectiles made. So just imagine something going really fast and it's really heavy, hitting the Earth or hitting the Moon or Mars. I mean, all the planets in the solar system all have craters.